So hi, Mike. What's the talk on tonight?
I don't have anything to present myself.
I still have more questions on a transistor. So do you put the electrical through the collector and the input through the base
I'm not sure what you mean by that.
on a transistor?
Uh-huh.
How does it get powered?
Let's see.
Through the collector, right?
It can, yeah. But again, it depends on what you're saying. Give me just 1 second to pull this up, because I don't want to answer your question wrong. Can you see that okay?
Yeah.
So transistors aren't like other semiconductor devices, like NAND gates and things like that, to where you have a VCC and a ground, or a VDD and a ground. It's not that sort of thing. So it's not like you need to turn it on, right? It's not like you have to apply power to a couple terminals. That's not the way it's working. The semiconductor device itself is looking at current flow from the base to the emitter to enable this junction. And then this junction will enable current flow in this direction magnified.
Okay.
So this is for an NPN device. So for an NPN device, you would possibly put, see, I think I've got a slide. Yeah. You would put your one higher power leg here, maybe ground here. And so the power is going to be running through this way when this junction is turned on, because of power running through this way. And then you're going to be detecting your output here. So think of this as a switch. So when this switch turns on, this node here becomes ground. And when the switch is open, then the power is fully supplied here. You will get, VCC less any drop through R2 based on your load. Does that answer the question? So it's not like it has power terminals. It's got, you do have power running this way, and then you've got power running this way, or current flow this way and current flow this way.
Yeah, so basically you can have a very small signal on the base.
Exactly.
And then, but I'm still curious of then the power is a emitter collector, is that a plate, or referred to as some junction or plate, or what is that they're both attached to?
No, it's not
Or they're both attached to the base?
No, they're not. Ignore what this symbol physically looks like. If you want to look at this symbol, this line here, you could think of that as the semiconductor junction. I think I've got a picture of it here. Here.
Does that connect the collector and the emitter together?
No, okay, no. So what happens is, this is what a bipolar transistor looks like here.
Okay.
There's some N-type material, there's some P-type material, and then some N-type material, and they're connected like this. You know, they're built together, sandwiched together. You can kind of think of it that way. And then what happens is, when there's base current going from the base to the emitter, it actually turns this junction on, allowing current to flow from the collector to the emitter. So it's all done as semiconductor junctions. Did I lose you again?
Well, not exactly, no, because you're still some signal, which is again, can be a very small electrical signal on the base.
Right. Well, it's actually, yeah. When there's a small current flow going between the base and the emitter. So for bipolar transistors, it's not just a small signal on here. It's actually the current flow going between the base and the emitter. And when you get enough current flow between the base and the emitter to turn on this junction, then it'll act as a switch and allow the collector current to flow through here. When we talk about MOSFETs, they work a little differently, and that's closer to what you were physically stating. These are a high impedance input, and basically what's happening here is you've got this P substrate here, and then they've doped little sections of it with N substrate, and then there is a what they call a depletion region right in this area. And what happens is, when a voltage gets applied to this, the electrical charge will make this depletion region actually physically open up. It's all done. Think of it as it allows more electrons to go through here, and then it turns on these two N, which are called your source and your drain. So it allows current flow between the source and the drain with just a little bit of voltage here. And with the MOSFET, it works a little bit different than the bipolar transistor, because if you remember, I said the bipolar transistor requires a current flow between the base and the emitter. Well, with a MOSFET transistor, they actually work a little bit differently, and it's just essentially this charge reacts in this little depletion region here and opens this up. And there's actually no current flow, or it's so small, we'll say there isn't any, between the gate and either of these two terminals. So there's really two kinds of transistors that work a little bit differently, the MOSFETs and the bipolars. But they both work in the same general concept, that you either have what they call a gate or a base, and then if you apply the appropriate signal here, you'll actually turn on the connection between the other two as they work as a switch.
So now, how does what is MOS, or yeah, what does MOS stand for? Because I have used an FET before. Is that a switch?
It stands for metal oxide. I think it's
And
metal
then
oxide.
FET, is that is an FET a switch?
No, FET stands for field effect transistor.
And then, so what happens when you make it a MOSFET compared to a FET?
Those are essentially the same. It's essentially the same thing.
Okay.
There's a couple different kinds of way they can build field effect transistors, and one of them is the metal on the silicon, which is the way this is. This is a metal oxide or metal on silicon or metal oxide silicon transistor. FET. There can't remember. There's a couple other ways FETs can be built, which isn't using the metal oxide silicon part. But the bipolar is actually built a little bit differently. It actually has, you know, the P junction with the two ends on each side, or if you're looking at a PNP, it's built this way.
Yeah, I use quite a bit of PMPs.
Yeah, NPNs are the most common. And when I did the talk, we talked more about the NPNs because they're a little bit easier to understand. Because you got the current flow going in one direction. This is actually labeled wrong. I was going to go fix this. This is the collector up here, and this is the emitter down here.
Yeah, I see with the symbol.
The emitter on these are always the one with the arrow.
Mm-hmm.
I hope that helps and not hurt, but it's basically you can think of these as a switch, and base to emitter current turns that switch on. Then you can do some cool things with biasing to where you can actually control that switch to where it's in a kind of on state, and that's how you build the amplifiers. Because it requires a certain amount of current to turn the thing on. It's not actually a voltage. This PN junction will come on at like 0.6, 0.7 volts, but it's not the voltage that makes it turn on. It's actually the current flow through here. To where with the MOSFET or the FETs, they actually work with the voltage being introduced on the gate region.
I see like on the PNP, where if that diagram's correct, how the emitter arrow was pointed in the
Into
opposite.
the arrow points in for the PNP.
So does that affect how anything's flowing?
Yeah, because let me share again.
That's like more like a diode directional.
No, it's the arrow in the symbol is just telling you in the symbol what type of device it is, if it's PNP or NPN for the symbol. But when the transistor is actually made, instead of the center one being P like here, the center one is N, and they put P's on the outside. So this is doped P, this one's doped N, this one's doped P. And then it works a little bit differently. The current flows in basically the opposite direction.
And well, it has something to do with the polarity though, right?
Yeah, exactly. Yeah, you can kind of think of it as they changed the polarity on it. a really good thing to do to kind of play with it is if you go into that one link for the that online simulator, you can actually pull up some transistor switch circuits and stuff, and you can actually kind of see as the voltage and the current changes how the transistor acts. And actually, it's very easy if you've got a NPN or PNP transistor. It's very easy to just breadboard one with, you know, literally like a small battery, and you can test it and see how it works.
Yeah, 'cause I don't know what's going on with the circuit I just built. I started out with PNP silicon transistors on a circuit. Then it wasn't functioning right. I wasn't getting like like a straight through signal and output. And now I've replaced the first transistor with a germanium, and it seemed to work a little better. Then it didn't work still good, so I replaced the second transistor with germanium, and I wasn't getting kind of anything, and my voltage changed on the collector on the third transistor, which it just has 3 transistors. I've got near input voltage at a resistor that connects to the collector. If I disconnect the collector of the third transistor where I'm testing the voltage, then I get a little over 8.5, almost 9 volts. I touch the collector to that resistor and it drops way down to like 1 volt.
That sounds like maybe you've got a biasing problem or something like that. Keep in mind that the transistor is going to act like a switch, you know, a physical switch. And so if you're connecting the transistor with a very low resistance or something on the collector to the power supply, and say your emitter is tied to ground and that switch is turned on, it's going to be like a dead short for your power supply.
The base is connected to the emitter with a 100K resistor, which then the emitter is going to a 1K potentiometer to ground, through the potentiometer to ground, and then it's got a electrolytic capacitor tied on the potentiometer to ground also on one of the
switching between germanium and silicon. You may have some problems just based on the bias voltages that turn things on. Germanium is quite a bit different than
well, I've rewired
silicon.
this. I rewired the circuit as it was intentionally schematic for PNP germanium, and now I've removed all the PNP silicons and replaced them with germanium PNP, and I'm stuck at, I guess you'd say, my voltage on that collector being at 1 volt unless I disconnect it from an 8 K2 resistor that's just after a Mylar capacitor, then it's going to go to output.
Without seeing the circuit, it's kind of hard to see, but my guess is.
I know, but I'm at the end of my circuit, the third transistor as the schematic was built, and I've built it before, but I don't know what's going on. I kind of like I did change transistors, or excuse me, resistors, after I was thinking that you know, I had a forward voltage was a lot higher with the silicon transistors, and so I thought, well, that maybe was the problem. And anyway,
Yeah.
I've replaced all 3 transistors back to the original
You're
requirement.
the resistors are really important. It's not like tube radios to where there's quite a bit of flexibility. You know, if things are off a little bit, it's still going to work. A lot of this stuff, if you're like your base input to your emitter, if it's off a little bit because the currents and stuff are so small, and it was originally designed for germanium and now you're using silicon, all of those set points that used to do the switching are probably not even going to be close.
No, I've turned everything back to germanium.
One thing I'd do is just make sure you plug the transistor in right. It's easy to make a mistake and get the, you know, the base emitter collector plugged in incorrectly. I would double check that real quick.
I've been doing
Kristen, on your germanium transistors, it only takes about 0.2 of a volt to turn it all the way on, and a silicon takes about 6.6 volts to turn it all on. So you got to be real careful with the base voltages.
yeah, like I said, I've already built this schematic before, enough times, and I just built it with silicon, and of course it didn't work very well. So then I've replaced all that back to stock schematics. I did change current and resistors to increase voltage, but when I had silicon in there, but it still didn't work. But now it's to the original schematic. I still can't get it working, and I don't know why, other than I've spent 8 hours and I'm done. So I'll just build another one because I don't know what. I've went over it too many times to see that it's connected, that everything's connected properly, and I still don't know why it's not working. As soon as I touch that third transistor to the 8K2 resistor that's coming off the negative power supply, 9-volt battery. But anyway, I've got almost 9 volts when I don't have the collector on the third transistor connected. And as soon as I connect the collector, it drops to 1 volt at the collector.
But my experience with stuff like this is when you're fighting a problem like this, it's usually something really, really simple. It's not anything complicated. It's like a little tiny miswire or something, you know, a transistor plugged in with the wrong leads. It's usually something like that. That's been my experience.
Yeah, I've went over it too many times though to check all that. So I'm thinking something's in air. I've got, and I might have a bad electrolytic. I don't know. I mean, that's where it comes down to me, where I've done it. I completely rebuilt a circuit before and it never worked. And I completely rebuilt it by component, and it never worked. And I couldn't figure it. I probably put 25 hours into that one. And it's rarely happened to me. This is only the second time something like this has happened, where I put another 8 hours into trying to figure out why it won't work. And so it's something that I don't know. That's what I usually do, is I'm at the point where I'm pretty much just going to rebuild it, and then it'll probably work.
Do you have another one that's functional?
Yes. Yes, I've built them before. And another circuit that I replaced every component one by one to figure out what component must be bad, and then it never worked.
Well, my suggestion is one of the easiest ways to fix things is if you've got an identical circuit that's functional, because what you can do is start from the beginning in your schematic, just walk through and test the voltages on one, compare it to the other one, and then walk through it until you see where the problem is.
Yeah, I'm off a little bit on, say, the collector of the second transistor. I'm getting maybe 3 volts or 0.3 volts on one and 0.24 on another. on the second transistor collector. So I don't know if there's a component problem. But I have had it happen before. I did 25 hours on a small, I'd call it small, not super difficult. I replaced everything in that circuit and it still never worked. The potentiometers, I replaced battery, terminal, I replaced everything one by one, 25 hours worth of, and it still didn't work. And I've only done that once, but it never worked. So I just didn't have a clue what was going on with it. Unless I could have grabbed another component that was faulty and put that in as something working. But I have small test equipment to, for a transistor tester. And I've got a capacitance tester and of course a multimeter for impedance and continuity.
So in the repair cafe, we've had a couple lamps come in that have been bad, and people swear that they've already tested it all the light bulbs are good. And more than once on multi-bulb lamps, I've actually found that all of the light bulbs were bad. And so all they were doing was just swapping them in and out with bad bulbs. I put new ones in that I knew were good and it worked.
Yeah, I test everything I change. I'm not putting anything in there that I don't run on a test. Every component I test anyway, other than prior, or maybe not the electrolytics. I might not be testing all the electrolytics as far as decharging them and then putting them on my capacitance meter. And that could be a problem. Just a bad cap. But I've checked all the other Mylars before I ever build it. So all the components, generally I'll get checked. Other than maybe I don't check all the potentiometers either. I just assume. But I did go through and check stuff like that to see if it's operating like the other circuit. So it just gets to me to a point where I thought I could learn something, and then if I don't think I can learn it, then I just wasted 8 hours, and there's no purpose in doing it other than trying to find out what it is so I could correct it. But it's too frustrating. And it's not that expensive, so it's just time wasted. With no education, same thing with another one, but I did a 24-hour on it trying to get it to work, and I built numerous ones. And this one circuit didn't work, so I started one by one replacing components and never got it working. Switch didn't matter, I changed it all. So it was completely, I guess I didn't change the wires. I don't think, maybe that was one thing. And maybe I didn't change the wires. So maybe I had a faulty wire, or I didn't check continuity on all the wires to see if the actual wires were working. But it doesn't happen to me very often. It just happened. So kind of like if I could understand why the voltage on that collector is the way it is, then it might answer some other questions.
Well, if it's dropping low like that, it probably means you've got enough base current to turn the thing on. And so it's that switch is on, which is gonna depending on what how the emitter is tied, is basically could be driving that close to ground.
Well, the emitter would go to ground, and the base is tied to the emitter through a 100K resistor. And then the emitter goes down to one end of the potentiometer at 1K. The wiper is tied to through an electrolytic, which is positive is wired to ground. The emitter goes from, it's wired to the potentiometer at ground, same as the capacitor. And then the negative is of the electrolytic is tied to the wiper of that 1K. So that would be controlling gain on that third transistor, or bias, I guess you'd call it.
Right. Yeah, it's raising the emitter voltage or up to where it's biased. And then the capacitor off the center tap of your variable resistor, that's probably just a bypass cap or a bypass cap preventing DC from going in.
Yeah, like I said, I've built the circuit I'd call it numerous times, so it's never something like this. I just decided I thought I would build it with the silicon transistor PNP, but I think from your talk, it kind of gave me an idea why it wasn't working, is because the silicon wouldn't work with that schematic. It wasn't built. The schematic was built with PNP germaniums.
Right. And so everything's biased differently. Yep.
Yeah. Well, then I started changing resistors in there to see how I could affect the current or the voltage.
And that's pretty hard to do unless you're doing the calculations.
Yeah, I never did. I just started changing them maybe to 10K and then 47K on other, not too far away from the original schematic.
Anybody have any iRadios? Or know of any iRadios?
All that's in riders is international radio, interstate home equipment, interocean radio, imperial. Nothing I ever heard of. That's just the riders listings. That's a tough one.
What was the other one that was tough? I think Q, well, was it Q or we didn't have anything? Hi, Linda. Hi, Mike.
Yeah, there's no Q in riders. Yeah.
Yeah, I think there was no Q, right? We quasar.
Wasn't that a Zenith brand?
Yeah, I think so.
I associate that with the quality goes in before the name goes on.
There you go. Linda, what's new with you?
Nothing. I had to think about it for a second, you know.
You had dinner with your daughter last Wednesday, right?
Yeah, no, it's been really quiet around here. They've been busy. But they do come over more often now that I have a barbecue.
Oh,
They
you
bought,
get a big gas grill?
yeah, they bought me a propane barbecue. And when they want barbecue, they all come on over and use it, feed me, and then leave. At least they clean up behind themselves. So, you know,
Oh,
it's not
that's
a big
good.
deal. Yeah, so no, I've been trying to clean up my office. I can't get in there. I can't get to my computer. I piled a bunch of boxes in there. I was emptying out the garage and put computer stuff in my office. And now I can't get to my computer itself. So I have to move things back out of my office and into the living room so I can fix. So the kids are going to be over this weekend. They're going to help me out. They're trying to figure out what to do for Mother's Day. Don't forget, guys. Not this coming Sunday, but the following Sunday is Mother's Day. So don't forget your mothers or your wives if you have children. So yeah, now this is the first year in 20 years that my kids have been able to celebrate Mother's Day with me. Because they live down here and I lived up there. And so we're not going anywhere because going anywhere on Mother's Day is an absolute impossibility. You know, you have to make reservations a year in advance and, you know, stuff like that. So they're probably going to come over here and barbecue.
There you go. That'll work. Huh?
Yeah. Nope, I'm just plugging away, gradually opening boxes, figuring out where things go. I figure it's going to take me another 5 years at least to unpack. But I'm finding things. Oh, something. I did talk to Julia from the Seattle Club, and I will be going up to Seattle for the August swap meet.
Shoreline. All right.
Yeah, but I'll be going early. I'm going up Friday because there's some people that I want to, you know, go spend some time with. But if there's anybody that needs something transported back, I'd be glad to do that.
Cool.
Just let me know in advance or let me know once you're there.
What did Jay call it? The SeaTac Express or something like that, right? Seaport Express or something like that.
Yeah. Seaport Express, yeah.
Yeah, Seaport Express. It
Yeah,
was
we're not going from
because
Seattle to
Portland.
Tacoma,
Yeah,
we're going to
Seaport
Seattle to
Express.
Portland.
Yeah, there we go. It's our little transportation between the two clubs.
Yeah, I mean, if somebody wants to go up early, I'll be glad to drive them up on Friday. I'm leaving here Friday. Going to spend some time with family or from friends. And I have a lady that used to do my nails. And she's been begging me to come up and do my nails for me.
Oh, that's nice.
So that's going to be my Saturday. But there looks like there's going to be a whole bunch of really interesting stuff going on. Have any of you ever been to the Seattle auction or the swap meet?
I have.
Okay. In front of one of the buildings where we usually, they allow us one classroom where we can plug things in so that people can test radios or use test equipment, that kind of thing. And there's a whole lot there, small parking lot, maybe holds 5 or 6 cars that was used for handicap parking. And it's no longer a handicap parking because they put a fence up or something. And so we're going to take over that area and have little workshops, they're going to have a table of things like for younger people, like, what is this? You know, put something on the table that they may have never, something of technology of our era, you know, put it on the table and say, do you know what this is? As like giving a telephone, like a dial-up telephone to a teenager, ask him to dial. But anyway, they're going to try and make it interesting for some of the people that are going to be attending.
Jerry's got a lot of that Flexit stuff, right? I think he was showing one the other day. We couldn't figure out what it was.
Oh yeah, well
Some
that
aluminum casting.
yeah, it's something that was used in a piece of equipment. You know, it had nothing to do with radio.
Yeah, maybe not.
But yeah, you know, there have been times I used to wander through the swap meet, and there'd be people that have things out on the table that had no clue what they were. They had a little sign on it that says, "Do you know what this is?" And about 95% of the time, we could tell them what it was. So just a piece of old technology or something that nobody used anymore. You know, when you've been around for a while, some of those things, you know, I remember that. So yeah. But yeah, it looks like between the July swap meet and the August one, it's going to be an interesting summer. And was it the Chehalis Ham Fest? Something that is going on. You were
Yeah.
there, Franklin, yeah.
But there's going to be a week ahead of ours, I think is what it is.
Yeah, well, they had put out a notice that they weren't going to be able to hold it because the prices had gone up at the fairgrounds,
Mm-hmm.
and they found another location. So now they will be holding it. So it'll be 2 things in July and 1 toward the end of August. I was going to go to the Highland Games up in Seattle, but because I'm going up to Seattle in August, I don't think I can do both. So maybe I'll go to the ones down here, the Portland Games.
.511 had a kilt that they were selling. It's a tactical kilt. I thought that was pretty funny.
There are a couple of companies that make non-plaid kilts.
These are olive green.
Yeah, for men to wear. And a lot of them like have a snap at the bottom of the kilt, so you can kind of snap it together so it wears like shorts.
Oh.
You know, but it's quite comfortable when it's really hot out.
I bet. Get a little breeze.
But you know, at the Highland Games, the guys wear a standard, you know, military kilt. The band players do, and they wear a white shirt with a tie and a black woolen jacket. And July in Seattle is not always cool. And we've had a few instances where they've been performing and have passed out.
From heat exhaustion. Oh my gosh.
Yeah, it gets, well, you're figuring you're wearing 8 pounds of wool and knee-high socks and a black woolen jacket and a wool, you know, hat. Yeah, some of them can, and you're playing a bagpipe, which isn't an easy thing to do. They managed to, a couple of them managed to pass out. They changed the format of the opening ceremonies to eliminate some of that, because they used to stand while they read some of the, you know, introduction of the guests of honor, and now they just come on, play a couple of songs and leave right away, you know, just turn around and go back out, and that keeps them from having to stand in the heat, because that the the area where the Seattle Scottish Highland Games are held is in a big bowl. It's the old King County Fairgrounds. And they've got buildings on one side that block the wind coming in from the west. And they've got a big hill to the back of the fairgrounds. So it just heats up in there. It just acts like an oven, like it put a dome over the top of it. And
So even
Linda,
being a
how
wedding,
long?
I'm so,
even being a wedding photographer, a lot of times you'll have the guys stand up and they'll lock their knees and they'll pass out and fall over because their knees are locked, their legs will fall asleep, and they're so nervous, right? Because you get them all, you try to line them
heart
up
rate's
and
going. Yeah.
Yeah.
Heart rate's going.
exactly, they'll fall over. It happened probably 1 in every 5 weddings that I did.
Yeah.
Somebody would fall and they just collapse, and it was like, oh no.
Everybody gets excited. Ah.
Yeah, exactly. I think that they died of a heart attack or something. But
Somebody else had a question?
Yeah, I want to know how long you can listen to bagpipes.
I love bagpipes. Sorry, guys. I've got CDs with
Yeah, I
Christmas
can't
with-
listen to them that long or over a long period of time, day after day. I can't do it.
Well, I would sit at the Highland Games and be there for 5 days from Wednesday to Sunday. And they're
that'd be
either practicing or playing. But I know, but the thing is, if you're Scottish and you've heard bagpipe music a lot, you recognize it. There's a commercial on TV now for Scott Lawn Turf, and there's
Mhm.
bagpipe music in that, and I recognize the tune.
yeah,
To me, it's not a bunch of cats in a bag. It sounds like music.
and there's
Yeah,
a YouTubers that play bagpipes with modern music, and it sounds great. I mean, I think it sounds even rock music and heavy metal with the bagpipe. It's kind of
Yeah.
really
Yeah.
cool.
If you think of it this way, though, there's some songs that you can't play on a bagpipe because there are no black keys. All right. It's, when you play a piano, you got white keys and black keys. There are no flats. Is that what it is? That's what the black keys are? All
Sharp.
sharps and no flats, no, all
Sharps.
flats and no sharps or whatever.
Yeah, it's no sharp.
And it's a 9-note scale. So learning a bagpipe is extremely difficult. But they start these kids really young. There's a high school in Shoreline up north of Seattle where they actually teach playing bagpipes. They actually have a bagpipe class. And so a lot of the younger bands come from there. They have competitions. It's fun to watch, but you have to, it's an acquired taste. I recognize that. Bagpipes are pretty hard. And the thing you have to remember is that they are an instrument of war. And they were used in battle to signal troop movement. And you can hear them for 8 miles. So you don't listen to a bagpipe indoors. Just too loud. So yeah.
I've noticed that a lot of a record, vinyl stores are opening up around Portland. And there's more and more of them. It's kind of interesting. There's one here that's going to open up. There was one over in John's Landing area that I saw. So it's kind of interesting.
You need to start advertising some of the old radios with the stereos in them.
Yeah, with the 33 long play radios, the vinyls in them, huh?
Yeah. Because some of these kids might be interested in it, especially if they're work.
I've been putting more postings on Facebook. I don't know if you guys have noticed it. If not, like and join and come into Facebook. We've got 3 different Facebook sections. We've got a page, which is a public page. We've got a Facebook group, and then we've also got a for sale radio group. So
yeah, I've seen the link on Instagram.
Oh, and Instagram too. Yeah.
Yeah, I follow.
Northwest Vintage Radio Society as a name, and it wouldn't fit in there. It's too many letters, so that's why I had to put NWVRS. So
Well, there should be radio in there somewhere.
NWVRS radio something. Yeah,
Yeah,
I can change it to Vintage Radio. Maybe I can do that. NWVRS and then put Vintage Radio. On
Yeah.
there. That way people can see it.
yeah, because you know if you Google the acronym, there are other organizations with the same acronym.
Yeah. They had the original acronym was NVRS, and that was taken up from, I think it was Nevada something.
Yeah.
Ooh, did you guys hear light thunder?
Just now?
Yeah.
Nope. You must have a storm over your way. Where are you? What
I'm
part
in
of?
the Milwaukee Gladstone area. I'm not very far from the Grange.
Oh, okay.
Saturday,
Yeah.
I noticed there was a bunch of fighter, those F-15s that were flying up there. They were just circling around real slowly. But
They're probably doing touch and goes at the airport.
it's kind of interesting. There was 3 of them that were just hanging out.
Yeah, you never know what the military's
When I
up
was-
to.
When I worked over on Sandy, one time the airplane, the F4, I think it was F-15 or F-14, came over and then it went ballistic. It was like crazy. Went straight up in the air and came, from right the building there on Sandy Boulevard. So we were right under it, and it was just crazy noisy when that thing took off.
Yeah.
And it just went out of sight and went so high up.
Yeah, where I used to live a quarter mile from Payne Field up in Everett.
Uh-huh.
And every once in a while, the Navy Growlers would do touch and goes because the runway at Payne Field is quite long. It was built for the 747, so it's a very long runway. So they were doing touch and goes until the whole city started calling the noise line and said, "Get those guys the heck out of here." Yeah, they have noise ordinance. Even Boeing isn't supposed to test engines after 10 o'clock because so many people complained.
They had the same thing with PIR, the racetrack here, but the racetrack was there before those houses were built in there. But they were like,
The same thing with the military. The military base was built there before they started building all these housing right underneath the runway.
yeah, it's
Whatever.
like,
Whoever possessed people to buy houses in that area, crazy, because growlers are, yeah, you think a regular jet is noisy. Multiply that times 100, that's a growler.
Yeah, they wanted to close down the Portland airport. Was a suggestion because the city likes the tax base, so they allow all these developments to be built around the airport.
Oh, yes. Gotta
I
have
don't
that
know.
money.
Oh yeah, they're getting more. Just wait until you start listening to all these grand ideas that the new government in Oregon has, because they have lots of energy. When they first take over, they got a lot of new ideas without erasing the old ideas that they said that they really had to have because they didn't have enough tax base. So
Yeah,
now we're
well,
getting
taxes have been a sore point for a lot of people for a very long time.
Well, yeah, but see that what they're doing is they're taking the taxes and then giving it away
Yeah.
for political points. So
Franklin,
you'll-
if we're not going to do the what's the I radios? What's the letter?
yeah, I. Mhm.
Can we go another letter?
You're gonna mess up my whole thing.
No, okay, never mind.
But you can show anything. You can show anything you want. But
I
I
got
got
it.
all in alphabetical thing, so we could go
Yeah.
back.
No, the only radio I have, I already showed.
Do you got
Yeah,
a
we're-
lesson today, Mike?
Yep, I'm here.
You got a lesson?
I don't, but I do have something on generic troubleshooting I could present.
Oh, that's awesome. Yeah. Hey, Larry, how you been?
Oh, pretty good. I'm working on a helicopter S-20 now that I picked up down there in Portland from that Bill guy. Let's see, what was his last name? Well, I told you about him, I think. Anyway, I got underneath of it and somebody cobbled in some capacitors for the filter, but they didn't disconnect the old filter. So, and the values were way off. So I'm cleaning
Remind me
out.
what a 20 is. Isn't that a great big heavy boat anchor?
That's what I specialize in.
Yeah. But right, that's a great big one, right? With a kind of an interesting dial face.
Yeah, they've got the round dial in them, and then it's got a band spread dial too. No meters or nothing in it.
Black
But-
drink paint. Is that right?
Really dark gray, I think, kind of a bluish
Oh,
gray,
really?
dark. I've got about 3 of them. This one here I just picked up real cheap, so I'm going through it now.
No, they weigh more than 50 pounds, right?
No, this is not too bad. It might be 25, 30, Franklin.
Okay.
Yeah. But it's got a good speaker in it, and that's hard to find in these. A lot of them have got warp cones in them, so they rub. This one here seems like it's free and it sounds good. So it worked before I got into it. Hopefully it'll work after I get done with it.
That's always the hope you don't do any more damage than it started.
Well, they say you're only supposed to do a few things and then try it out again. But sometimes I just threw a clean house in them. I know it's not always a good way, but that's the way I do it. Clean house, and I've got schematics and everything, and I've been in radios all the time, so I don't get lost. I got good road maps to go by. Also, I got a couple other ones for patterns if I need it. And then I got a S43 that I'm going to start on next. And it looks like a halfway decent one, but the band switch is dirty in it. It probably weighs 35 to 40 pounds. It's a little heavier. Got
How
more in
many
it.
38s and 38As do you have?
Let's see. At least a half a dozen.
It seems
Yeah.
like every collection we get like you said, a half a dozen of those, both of those. Yeah, they were a prolific radio, weren't they?
Yeah, I got 38s, B's, C's, D's. Don't think I got any E's.
Oh, what you
38
showing
E's.
there, Linda?
This is a poster that I found. It's called The Evolution of Radio.
Oh, that's super cool. I like that.
And it starts 1901.
How
Marconi
close can you
sends-
get to the camera?
Huh?
How close can you get to the camera? There you go.
I have to reverse roll it to keep it from rolling back up again.
Oh yeah.
But
Well, that's cool. It starts with a pup.
Yeah, it's got a timeline across. And then it's got pictures of a whole bunch of radios, you know.
Oh, and there's a bluebird.
Yeah, but yeah, there's a, so what it starts at 1901 with the Marconi sends the first radio signal across the Atlantic. And then KDKA 1920. KDKA broadcasts the Harding-Cox presidential election returns, ushering in the new area of radio broadcasts for home audiences. And in 22, approximately 250,000 home radio receivers are manufactured in the US.
Wow, that's crazy fast.
1924, RCA brings out the first super hat developed by Armstrong. In 27, RCA releases a new generation of alternating current tubes, making possible light socket powered radios with enclosed power supplies. And the need for cumbersome batteries is eliminated. And in 1925, 4.5 million radios are manufactured. So, and at 33 is FM. 35 octal-based metal envelope vacuum tubes are introduced. 39 is loctal-based tubes. 40 miniature tubes. 41, 13 million radios manufactured. And 1942 to 45, US involvement in World War II brings a halt to production of home radio receivers as manufacturers shift their focus to supporting the war effort. And then 1947, scientists at Bell Laboratories developed the transistor. And then in the 1950s, the golden age of broadcasting comes to a close as many of the core radio programs move to television, taking their audiences with them. But they have pictures all over this. They got a 1923 Atwater Kent, a 1925 Crosley Pup, a 31 Philco 90, and a Radiodyne Junior from 25, 1935 Jackson Bell Peter Pan, 36 is the Spartan 506 Bluebird. I've always wanted one of those.
I got a 1068 Spartan.
Yeah, so there's all kinds of really interesting pictures of radios on this. It got a little damaged.
So
It was rolled up
are
in
you
it
gonna
was
put,
rolled up in a tube, and then somebody bent it.
are you gonna put that poster on a piece of cardboard? Or put it on your wall?
I'm thinking of having it framed so that it can be flattened out. Or I might just roll it up and put it back in the tube and bring
So
it
is this
to the,
something you found in your things you brought down?
apparently this is something that my husband collected at one time. Because it was in with all of his radios, and I saw it and I said, oops, I gotta keep that one. But yeah, it's paper. It's just paper. It's on a nice shiny white paper. So it's,
Who printed it? Does it have a mark of who printed it on the
yeah,
corners?
Sonoran Publishing LLC in Chandler, Arizona. So. Yeah, it's an interesting poster.
Yeah, thanks. It's always nice seeing stuff like that because that's pretty informative. Get you a little further than I was, and then you're supposed to go check out the books.
That means I got 2 years left to find a pup. It'll be a 100-year-old radio. Then I can show it at the 100-year-old radio thing.
Oh, yeah.
I've been very close to getting one, but have never got one.
Yeah, some of those things are rare enough that they start going into the astronomical prices that nobody's willing to pay.
Well, that Bluebird is just really crazy price.
Oh yeah. Well, a lot of the plastic, the Catalan radios.
Oh yeah.
And the stuff from. Yeah, they have a lot of. 1956 GE clock radio, 59 Motorola Z7X245. That's that radio there. So yeah, they show a lot of on the poster, they show a lot of the older radios. And we used to have a guy in our club that collected Catalan radios. He didn't care whether they worked or not. They just had to look pretty. And he brought some to the contest, and they were, like mother of pearl and just really Art Deco, gorgeous radios. But he dropped out of the club, so we haven't seen him for a while.
Are you ready, Mike?
I am. I have a poster too. I don't know if you can see it, but I picked one up at an estate sale. It's on the wall back there. It's a exploded view of a South Bend metal lathe. So
Oh,
I'm into machine tools too. So
Yeah.
well, let's see. Let me do a share here. It's not as cool as your poster though.
Oh, thank you.
So I don't think I've showed this before. This is a document, part of a document that I've written for the repair team, the repair cafe that I work with. And I'd be glad to get additional input from you guys. I know you guys are great at doing that. But this is a more general repair thing over my many years of having to fix everything, or for some reason having everything break on me. I've kind of put this together, and you could pretty much apply this, in my opinion, to fixing almost anything. Number one, not everything is repairable. Sometimes you just have to make that decision, as hard as it is. The other one is the internet is obviously your friend. YouTube is amazing. There's so much documentation on there. How we ever fix things before YouTube, I really don't know. One of the key things is really gather the right tools ahead of time. Muffin tins work great for organizing your screws. One thing I have that I really love, I pick them up at garage sales and stuff all the time, are these silicon trays for ice cubes and stuff.
oh,
They make great parts holders. So, as you're taking the screws apart, you put them in there, keeps them organized. The nice thing about the silicon ones, they fold up and you can, jam them into a drawer real easy. I've got these all over the place, and they're really helpful for organizing.
that's what I
Now,
was going to say. Trays. Ice trays work great for pulling things apart. You can keep them separate, especially when you got different size screws.
Yes.
In the appliance business, I always used one because that way you can put, okay, like if you take an outside ones, you can put all those length of screws in one, and then go to the next one, take the shorter screws, stuff like that. Because a lot of times people will put things back together and they put the longer screw in a short, place where it's supposed to be short, and you can mess up a lot of things. So
Yes, I've actually fixed a Sony radio somebody took apart. It was one of the Walkmans, and they'd put a small screw or a long screw in on the side, went in and was shorting out the circuit board. So one of the tricks that I do, I don't happen to have a picture right here, but I actually will use a piece of cardboard. And like if I'm taking something apart, I'll draw a picture of what the thing looks like on the cardboard. Then I'll physically stick the screws into the cardboard. I'll use a ice pick and I'll punch little holes and I'll put the screws in so that I keep them in the exact same order. Because as Franklin mentioned, one of the real problems is screws can be of different lengths, different heads, things like that. And so anything you can do to keep track of those is really good. Having a good work surface, your screwdrivers, flashlights, microscopes, all that kind of stuff can be helpful. If you're trying to disassemble something, a lot of times disassembly is one of the hardest things. Fixing it's really easy if you could just get the darn thing apart. A lot of times I find if I'm really struggling, what I'll do is I'll just kind of stop and then step back and look again, because a lot of times there might be an easier way to get in than what you initially thought. Especially like if you're trying to take a an LCD TV apart or something like that, or a computer monitor. A lot of times, maybe it's not, you don't get in from the back, you actually have to take the front bezel off.
I was
So-
gonna- unless it's an Apple product, then you can't get into it no matter what.
Let's see. Before I do most any disassembly, I take pictures of everything from multiple angles. That's the great thing about cell phones these days. You've always got a camera with you. And I highly recommend taking pictures at multiple angles. I even do it with the radios I work on, because a lot of times if you've got, you know, as you're working on something, small wires can easily break off. And, you know, if you have no idea where they go, having that picture can really save your bacon. A lot of the reason why things fail in general is it's heat and movement. If something gets hot, like power supplies, things like that, that's a great place to start looking. I probably fixed 90% of my stuff, that, you know, appliances, things like that that come in the power supply, because that's where things get hot, and that's going to be one of the things that it goes. The other thing is switches, anything moving. If there's anything moving, if people are plugging things in, anything like that, that's a great place to look before you go anywhere else. You know, just scan all the places to where things get plugged in, anything that moves, anything that might get hot. More than likely, you're going to be able to find the problem right there. Any power cables, connectors, anything like that. The other thing is what I call the things that turn off. There's a lot of equipment out there that has all kinds of safeguards. You know, there's fuses, there's circuit breakers, there's thermal fuses, even inside of motor windings, like in fans. You can actually take the motor winding apart, and there will be a little thermal fuse in there that's replaceable. There's also tilt switches and a lot of heaters, things like that. You know, look for any of those kind of things, because there's all these circuit interrupters. There's even things that if you take the back off, there's an interlock switch that may pop so that the thing won't run. You know, looking for all of those things. And quite often those things, either the wires to them or the switch itself could go bad. So it's not that the thing isn't like the back isn't properly on. It could be just that. I had my gas fireplace. There was one of the thermal sensors up at the very top corner. I couldn't even see, had gone bad, and that was the cause of it. I like to think of use all your senses, other than maybe taste. You don't have to use taste. Although I do check 9-volt batteries that way, but that's just me. You know, burn parts have a smell. If you hear something buzzing, humming, grinding, look for anything that looks burned or discolored. Look for loose or broken wires, metal shavings. If you've got dust or any kind of a wear, don't bother continuing to do your repair until you resolve those issues. It's amazing. I can't count the number of times I was stupid to where I saw something that looked obvious and I thought, oh, I'll have to get back to that. Well, that was actually the root of the problem. It didn't seem like it would have been, but sure enough, that was the root of the problem. You know, you can also feel things. If things feel loose, or if they have slop in it, if they feel hot when they shouldn't, you know, watch how things move. If there's something moving, if it's glitchy or bumpy, you know, stop before you go. I mean, it could be as simple, even if you look at a All-American 5 radio with the capacitor, the tuning capacitor. You know, if one of those tuning plates are bent and you twist it, well, you could be shorting out your capacitor. You may not figure out why the radio is working because of that, but, you know, if you felt like, oh, maybe it's grinding a little bit, go look there, because that, you know, that might actually solve your whole problem. So if anything looks bent, any foreign objects, I remember working on lots of things to where I found pennies and nickels and quarters. I don't know how they get into stuff, but they tend to, and you know, it can actually cause shorts. Look for corrosion, especially on battery terminals. If you find corrosion around a battery terminal, look around it, because that corrosion will actually eat away at wires. I've seen to where wires look good, but they've actually corroded inside the insulation. If you go and pull on it, the wire just pops off and you're going, oh, well, it wasn't even connected in there. So, those kind of things. Don't just say, oh, I need to clean that up eventually. Go in and actually check around it. That could be a problem. One thing to really be careful of is symmetrically looking parts. So I'll use a diode as an example. A diode looks like it's symmetrical, that it's got a lead on each end, but it actually matters how it goes together. There's a lot of things like that, maybe the holes are just slightly off, center or something like that. And it may not be obvious, but especially when you try to put something together, look carefully at how they're oriented. A lot of times I'll even mark things with tape or with a marker when I take it apart, because it may look symmetrical, but it's really not, and if you try to put it in the other way, you'll never get it back together again. That's really common in things like, cassette players, record players, things like that. Lots of little components can look close, but they're actually not. And it won't fit back together, or you're going to be struggling with it. Shafts and pins can be slightly tapered. They're intended that way to where you push them in and they'll stop. So you can't put them in one way, but you can put them in the other way. So, be aware of that. The troubleshooting steps I take is I try to identify what the problems are, a lot of times through the symptoms. When someone tells me that something's not working, I listen to what they say, but most often people don't tell you what the problem is, although they're going to tell you that. Here's the problem with the radio. They're actually saying, here's the symptoms I'm seeing. And you have to differentiate that. Don't get too caught up on what people tell you. Look more about what the symptoms are and then think about what the problem could be. And is it repeatable? Unrepeatable problems are the worst. I'm sure everyone knows. If it's repeatable or it's completely dead, those are usually a lot easier to fix than the things that are just really sporadic. And then you need to ask yourself, did something change? How long has it been happening? Did it work well before something happened? Because maybe you made a change to it and then it worked great for a while and now it quit working. Well, maybe you didn't do that change exactly right. That's the kind of thing to look for. Was it being used for an unintended purpose? Is someone using a blender for grinding up circuit boards or something? That could explain why the motor burned out. Can you do something to make the problem worse? Maybe with a radio. If I change the volume control, does things get worse rather than not? All of those things can help you identify what the problem is. And I think this goes really good with the radios too. Before attempting to use an item, make sure that nothing is dangerous before you even start. I can't count the number of times just looking at a power cord, you're going, oh my God, you actually plug this thing in. There's bare wires or it's hard and broken. I've got one that I use as an example for a lamp repair class that I literally pulled off of a lamp to be repaired, to repair a socket. And I wouldn't do it until I replaced the cord. But the thing has about 30% of it is bare wire, because the insulation had just cracked off. It was just really scary. Actually, let me stop here. And if anyone wants to comment on anything I've said up to this point, that'd be great.
I was going to mention one thing that came across the Google groups, and I've ran into this before, and it's one of the toughest things is a stripped out head or screw on a set screw on a knob on a radio. And I've fixed them before. I have a couple different things that I've done on that usually. And if it's a slotted screw or or Allen, either one, and it's stripped out. So then, and the thing is in there really, really hard, you know. If you have enough room, and this is the trouble, because sometimes you don't have enough room to get in there and drill it out. You can do that. Sometimes those things are really small, or like 632, you know, screws, and so it's kind of too small to where you start looking at easy outs and stuff like that. If you can ever get it off, usually then at that point, then you can fix it. But it's just like you said before, it's getting it off or getting it apart is the big challenge.
Right.
And I've, you know, then of course you try the simple things like the WD-40. I have a set of left-handed drill bits, and believe it or not, those things work really well, because sometimes if the screw isn't extremely tight, now there goes my internet again. I'd like to fix this. Anyway, if the screw isn't extremely tight, then you can, let me move the modem. That sometimes helps.
Yeah, I have those too, and I
There you
found
go.
that works on
Then-
the Allen
Do
screws. They
you?
work really well.
Yeah, you get the left-hand bits. Sometimes it'll
Yep.
pull it right out with the drill bit, and that's great. And, hey, wow, you fixed it. So, do you have any other tricks? I've tried those. I've tried little tiny easy outs, and sometimes you just have to drill the screw all the way out, and then just so you can get it apart.
Yep. The other thing that I have done is, and actually this works really well for flatheads and Phillips. If you can get a rubber band on it, if you put a rubber band on it and then push the screwdriver in, a lot of times that rubber band will make up the difference,
Yeah.
allow you to easy it out.
Yeah, like on an Allen, that would work really good on an Allen that's really worn out really bad. And then you know, you can't get, sometimes another thing on Allens, which is really cool, is if they're worn really bad, get a set of metrics, and then you can go to the next size up, because sometimes they're really close. And
Yes.
it'll be enough if you can force that in there. Or like what you're talking about with the rubber band method, that works too. On now on Phillips, that's a good one. Is put the little rubber down in there on that too. Yeah,
Yep.
that's a good one.
Another thing I've done, because sometimes the reason it depends on why it's binding.
Yeah.
If it's binding due to different alloys, you know, like an aluminum steel, that's really hard. And that I'll use kerosene, or WD-40 works really good with aluminum.
Right.
But sometimes what I've done is if it's like a real small screw, maybe they put some fingernail polish or something like that because it kept backing out, or you know, Loctite. What I'll do is I'll try heat, and I'll take a screwdriver and I'll put a really big soldering iron on it, and I'll try to heat it up that way.
Yeah, I've done that too. Soldering irons work really good for that. If you can, the trouble is, you may end up ruining the knob.
Yeah, if it's wood or if it's plastic, yeah.
Yeah, but a lot of times the knobs can be replaced. You know, that's better than the whole radio being trashed, you know, over that.
Right.
So yeah, that's a good one, Mike. Yeah, yeah.
But yeah, those kind of things are some of the hardest. Larry, you had a question or a comment?
Yeah, Mike, I've used Torx screwdrivers in some of the stripped out Allen screws.
Yeah, yeah, you're right. That's right, Larry. I've done that too. That's another good one for sure.
Yeah.
Yeah, those kind of things. In fact, I just recently, not more than yesterday, I had to work a screw out that fortunately it was a larger set screw. I was able to get it out, and then I had to use a Dremel and cut a new slot in it. And I ended up putting it on my lathe, and I turned a whole new screw because the thing was just shot. But having a lathe is also really nice for building those things.
Yeah, for sure. It is.
Nice to have a machine shop.
It makes it a lot easier. Sort of. The other problem is you're always fixing stuff because you've got a machine shop.
That's a good point. Yeah.
Yeah. So it's a double-edged sword.
It is. That's one of the tougher ones.
Yeah. So again, you know, looking through a lot of this stuff, disassembly, especially, you know, as Mike mentioned, you know, stuck screws, things like that. it can be really scary. And in a lot of cases, it's not even obvious how they come apart. Mike, I think you were mentioning before, you had a knob that actually didn't come all the way out. You pull it out and it stayed in the radio. You know, that's where.
Yeah, that was made that way by design. And that was for a hot chassis radio.
Right.
That and they did that. Zenith did that so that, you know, some little kid couldn't pull the knob all the way out when it was plugged in and then reach in there and touch the shaft and get shot. And so they designed it that way on purpose, you know.
Right. So you gotta, when you're taking something apart, look and think about those things, you know, because it may not be obvious. You think, oh, that knob's going to come all the way out. Well, maybe it's not supposed to.
Yeah.
You know, and before disassembly, you know, look for the obvious. Nothing's too simple. You know, a lot of times you can fix things without even worrying about it. I fixed a toaster just because it wasn't plugged in. It was a brand new toaster, and the lady brought it in. She goes, look, when I push the button down, it won't stay down. And I go, well, let me try it. So I plugged it in and it worked great. I said, well, there's a solenoid that holds it down. And I said, it has to be plugged in to work. And she did not know that. So, you know,
Sure.
Don't be tearing it apart just because, oh, it must be something wrong. A lot of times it's really obvious. We had a lamp come in that wouldn't turn on, and I struggled with it for a minute until I realized someone had rewired 2 additional switches on the thing. One was on a power cord.
Oh, wow.
And so there was all these switches, and they all did the same thing, but they all had to be turned on to get the light bulb on. You know, and so you know, those kind of you can never trust what someone else has ever done on your radio or anything, any appliance, because if someone's got into it before, no guarantees, all bets are off. And I'm sure everyone here has horror stories. Well, I think, was it you, Larry, that was mentioning about the radio you just got into with the capacitors and all that?
Yeah, filter capacitors are just kind of lopped in there. They weren't even tied down or anything. Well, you've seen those kind of horror stories before.
Yep.
Yes.
And so also look for if there's other missing parts, things like that. That'll give you a hint someone's probably been into it before. And then if you start seeing those kind of things, you know, look with a more skeptical eye. Don't just make some assumptions that you know the thing is not broken or that it broke in a certain way. Make an assumption someone maybe got into it and actually did it. You'll never know for sure.
I was going to mention, I got into one, and here's a tip that I just kind of discovered inadvertently, because I was working on a 1929, it was a Stuart Warner, and what happened was it had wet electrolytics in it, and they, like they always do from that era, they leaked, and the electrolyte came down out of there, and then it got the white acid electrolyte all over down below. And I found a product at the auto parts store. It's in a little spray can, and it's designed to fix corrosion on car batteries. And that stuff works absolutely wonderful. It's not so good so much to spray it on a radio like you would a car battery, because you know the stuff goes everywhere like that. But what I did was I sprayed a little bit on a little acid brush, okay, that way where you could control it. And then I got it in there right around all the parts. It happened to land, of all things, right down on the tube socket for the rectifier for the 80. And so I wanted to get that all cleaned out of there for sure. And this stuff, it was a great product. I can't remember the name of it because it's out in my radio shop. But you can get, there's all kinds of different products like that will clean the battery acid off a car battery. And it works wonderful for that electrolyte that leaks out of those old electrolytics out from the 20s.
You know, when we're talking about batteries, be aware that like alkali batteries are different than the old lead acid batteries when they leak, and you actually don't want to neutralize the thing the same way. You know, with alkali batteries, I believe you want to use like a baking soda versus a vinegar, you know, those kind of things. So make sure you know what kind of leak you have with like the electrolytics, that's probably a neutral, I would guess, but it's, how do you find something to clean the thing? But
Yeah.
I use for alkali batteries, I typically use baking soda to neutralize it before I clean it.
Okay. Well, that's a good tip. That's a good point. Yeah. I wasn't even aware of that. I thought they were all pretty much the same, but now I'm finding out different. Yeah.
Yeah. The alkali batteries actually, it's a different pH that's leaking. It's
Versus like if you had a fairly modern, I say modern within the last 20 years, Duracell battery now that leaked. What is that's not an alkaline battery, is
that
it?
more than likely those are alkali. I don't know if
Oh.
they're making any of the old the actual acid batteries anymore.
Oh, okay. No, that's an alkaline. Yeah, right. And it has the white powder that comes out, leaks out, and
Exactly.
makes a
Baking
mess.
soda.
Yeah, that I use that battery cleaner stuff on that, and that absolutely worked wonderful. It just dissolved it. So it must have the same properties as baking soda then. So you may not even need to go to the auto parts store, just get some baking soda. Maybe that's all you need.
Yeah, so part of it is about the neutralizing. I try to neutralize the alkali that's leaking out. That's with the baking soda. And then cleaning, I'll usually use isopropyl. I go through a lot of isopropyl.
Okay.
Yeah.
Okay.
Nice thing about isopropyl is it'll evaporate and leave everything pretty clean. I try to use the higher percentage isopropyl. I'm not a fan of the 70%. I try to use the 90 if I can.
Okay.
And that's because the percentage is the rest of it's water. And if you're using 90%, when it evaporates, it's really clean. The 70% will leave you a little bit more water residue and it'll take a little longer to evaporate.
Okay.
Yeah, I got a gallon of that stuff. That's good stuff.
Yep. Yeah, I've got 2 gallons sitting here, in fact.
That's a good tip. I really appreciate that, Mike. That's a really good pointer on that.
Glad to do that.
I've got isopropyl, but I'll check the percentage on it. Yeah.
But even 70 is okay. But if you've got the higher percentage, you'll find that it'll evaporate a little bit better with a little less residue.
Oh, great. Great. Okay.
I had a German set about 1960 or something like that. And the potentiometers are like cast rectangular or square housings. They're not the potentiometers that we have in America. And the volume control was just stuck like a rock, and the shafts, they're not D shafts or anything like that. They're totally round, and the knobs go on the set screws. And so I didn't want to bugger it up by putting like vice grips on there or something, right? And so I couldn't turn it at all. It was just totally locked up.
Wow.
And it turned out that, whatever lubricant they used that year basically sets up. And they have tight clearances already. And it took, my old Win 100-watt soldering iron, put that on there and got it good and hot, and then it started to move, and then finally it moved,
Wow.
But it took like 20 minutes to heat it up. It was really interesting.
So you're saying that the lube they used was some kind of grease or something, and then that stuff just froze up in there?
Yeah.
Because
It has a very low clearance anyway, not like our, the volume controls we're used to. And there's a lot of a long area where the shaft contacts the pot metal or whatever it is.
Oh.
And so you can't even put any lube, you can't even dissolve it or anything because it's like a half inch or something contact area,
man.
But the heat was the answer, but it just took a long time.
Yeah, when I'm undoing stuck bolts and stuff, and if I'm using my torch or something like that, even a propane torch, normally I'll have to heat it to almost red before it's going to come loose. And obviously you're not going to be able to do that on a potentiometer. But
Yeah, for sure.
But
I mean, I got it maybe 100, 110 degrees or something,
Right.
that was all I could handle, but
the
then it
nice-
just barely started moving.
yeah, a lot of those kind of things I found are usually it's the grease just is seized up. It's dried up over the years.
Yeah, that's what
and-
I was saying. Yeah, the grease, right?
Yeah, I mean,
and-
on the internet, they claim that it was only like a 2-year period that this happened.
Really? Oh, I'll be darned.
Yeah, and acetone and isopropyl both. Acetone is really good about getting into spots and help loosening things up. And what I'll do on something like that is before I'll go with the heat, I'll usually try a little bit of acetone, and then I'll work it back and forth and see if I can get it to start to come loose. But then I'll go with the heat if I have to, and I think it's safe to do. But yeah, that heat can help. It's amazing what a little bit of heat will do. Unfortunately, it's not always easy.
Right, and then you have to be cautious depending on what kind of control or what you're working on, so.
Yeah, absolutely.
Yeah, I mean, those are totally unobtainium, they're square, hot metal housings with a sheet metal on the back of them, and they have taps on them. I mean, all you can find is part sets.
Holy cow. And that was what brand of German radio was that?
I think this was a Blaupunkt from about
Okay.
61,
Oh, okay, yeah,
fairly modern not the older
Right.
ones.
right.
Yeah, there's also a lot of different metals that were used. Zamac is one, and they're like an aluminum zinc alloys, things like that. And you actually, soldering irons are okay, but if you're going to try to use like a propane torch or something, certain metals you might find actually have a pretty low melting point, and so you really have to be careful. But you'll be safe usually with a soldering iron. But although I did fix this one sculpture this lady had, and it was all these leaves and everything. It was really thin and beautiful, and a couple of the branches had broken off, and she wanted it put back together. And I said, well, I think I could solder it, and I heated up. It was only like a 60-watt iron, and I went to see if I could solder it, and I found out the thing was actually made of solder. And I touched it, and it just poof, it disappeared. And I go, oh God. But fortunately, I touched this one little piece that I was able to actually rebuild. But that's where you got to really be careful. Think, oh, I'll go in there and silver solder it. And the next thing you know, you got this pile of solder. Go,
Oh,
oops,
man.
you got a paperweight now, lady. Yeah, so you do have to be careful. Always start. And actually, that's probably another good thing to talk about. Anytime you're using heat or chemicals or anything like that, start off slow and then work up to the more aggressive. Before you go to the propane torch, start with a soldering iron. Before you start using, ethyl xylene or something like that, start with isopropyl, then go to acetone before you go to the next level. It's okay to fail a bunch of times to get to the point. It's not okay to start and really ruin something, because you went too aggressive to begin with.
Yeah.
Another thing to look for is error codes. A lot of new stuff actually has error codes that may or may not be obvious. A lot of times you'll see even like the Roombas, when if they go bad, the robot vacuums, there's an error sequence you can do. If you click a couple buttons, it'll start beeping and tell you what's wrong. And there's a lot of the newer appliances that are that way. I just recently fixed a printer. It was a color multi-function printer for a guy, and he brought it in. He said the thing doesn't work anymore; it's crashing. Well, I just went through the menu and I found the error status. I found the error codes. It told me exactly what the problem was. It said firmware out of date, not compatible with Windows. So I uploaded new firmware into it, and boom, it started working. So you don't always have to dig into something, especially on the newer stuff. There's a lot of times there's error codes if you can find them. Either a lamp will blink a certain pattern, or a beeping. Sometimes you have to do something to get into that error mode. Sometimes it'll show you right away, but it's always good to look for that kind of stuff because it can save you a lot of work.
Yeah, it works on your car too.
Yeah.
If you've
I
got a
had-
fairly new car, I've actually, they forgot to erase a code after they finished updating my car. And so I kept getting this error message on my dashboard. And so I looked in my manual, and it said, push your trip meter hold the trip meter down, turn the car off, turn it back on again, and it'll erase it. And so I've actually
Cool.
written that into my phone.
Well, that's easy. Usually you gotta have a scan tool to erase a lot of, any kind of a code like that, if it hasn't been erased, you know, from the work. I
Yeah, well,
had
they
actually
were
another
some
one,
oil-
you're talking
oil
about,
changes.
Mike, you're talking about YouTube. That's a real handy tool too for error codes. I had one on my washing machine, and I looked in my, you know, owner's manual, and of course, it I think it just said something about, you know, call for service or whatever if you have this. Well, I just entered the make and model of the washing machine on YouTube, and it said error code such and such, and man, it just brought the whole thing. Somebody had showed what you do to find out what that error code and what was causing it. And in my case on the washing machine, I think it was turned out to be the pump. And that's another one where, you know, you had quarters and dimes end up in your washing machine pump, you know, go figure.
Yep.
And that ended up being it, but it helped to diagnose it, you know, to find out, well, what's causing this, you know, it's got error code E2, you know,
Right.
or whatever it was. And then you can nail it down. YouTube is a real handy tool for that one.
It is, and it's quite amazing how many things now there actually have the error codes. It's always worth looking into, you know, and again, it's not always obvious. They don't always show you. Sometimes you have to enter into something to do an error code or a you know, a diagnostics test.
Yeah.
But you know, again, that's where the internet is awesome. It can show you how to do that. You know, hold your left arm really high, hit one button 3 times, and blink your eyes, and then it'll
Yeah.
go into that mode.
Yeah, I come from the automotive field, and there's so many on cars. There are so many, you know, when your check engine lights on, you know, there's a trouble code for that, for some causing that somehow. And quite more than not, you know, you're going to need either to have somebody that has a scan tool, or you're going to have to get access to a scan tool and plug it in. And then from there, then you can troubleshoot it.
Along those lines, it's something that pissed me off a couple years ago was my Ford F-150. The battery went bad, so I went to replace the battery. I found out I couldn't replace the battery myself because once the battery is replaced, Ford will charge you, but they have to initialize it.
Yeah.
And what do you mean I can't replace my own?
Yeah,
battery?
it's crazy. They got all kinds of crazy stuff like that, Mike. It's
Yeah, I was not happy.
no, I know, because they've got you, you know, and then you're forced to go in and have somebody you know, reset it, recalibrate it once you have taken the battery out, and of course all the voltage has gone out. But there's keep alive voltages that stay active, that to keep the computer alive, you know, once you take the battery out, you know, unless it's out for a great length of time. But you know, even beyond that, then they have stuff in there that they've engineered into the thing, so then they have to recalibrate it with their scan tool, and it did piss you off.
Yeah.
Well, we had our e-car in the body shop, and they said, oh, well, we have to turn it off. You know, we have to disconnect the battery, right? And I was like, well, you know, then go ahead, right? And they're like, no, we have to take it to the dealer. And so I went online, and there's a service manual for first responders that tells you how to disconnect the battery.
Yeah.
I thought that was really lame. It's like, you know, you can't look that up. I looked it up. I mean, it's a big red switch. You open the hood and there it is. It's like, you know, so they had to tow it to the dealer and tow it back. And then when they turned it on, they had to do the same thing again.
Oh my gosh.
It just took time. I mean, the insurance company paid for it, but still.
Yeah.
So maybe I need to change this next one a little bit. I'll say anything with electronics other than your electric car. You know, look around the power supply because quite often that's where the faults are. Let me just show you here. So here's some examples of some of the problems that I found. here's an example. This soldering area right here. Anytime you see on a printed circuit board, you see cutouts like this. They actually do the cutouts to help block stray electricity, jumping between things. So anytime you see cutouts on a board, first place to look. Anytime you see really thick, heavy traces like this, or traces that have a lot of solder on it, first place to look, because those are always your high current areas. And here's the case right here to where this solder contact is literally burned open. And all I had to do was resolder it and get it up and going. Here's another example. Here's what they do is they'll take a normal trace and then they'll solder the whole thing. And they do that to actually make it thicker for more current carrying capability. It's cheaper doing that than it is getting heavier density copper boards. So they'll do that. And again, here you see the cutouts. Here you see the thick solder. First place I looked, oh, there you go. Here's two contacts that had burned through.
Sure. I had one.
Aren't the cutouts mostly for isolation though? Like,
they're
high pot?
Yeah,
they're all for isolation.
for isolation. Yeah.
High pot.
And so, but that's a key point. Whenever you see that, go look around there, because a lot of times you don't even have to troubleshoot further than that. This is going to be the area of the board that you're going to want to look at. Now they might do something like this. This is probably an optical coupler sitting here that they did that. But
Wow, that's really good to know.
But yeah, that's quite often I'll go look for the board here, and then that's where I'm going to find my problem.
Sure.
Here's an example of a cold solder joint. If you see how it looks kind of grainy and gray, and that was the problem. I resoldered these and reflowed them, and then they work great. And what will happen quite often, and this is the case here, you can actually see how the wire is cracked right there from the solder.
Yeah.
That will, I look at a lot of this stuff under microscopes to find it, but this one was pretty obvious. Once I saw that crack, I knew that's the problem. It's hard to believe, but that wire is actually not connected to this. It'll over time, it gets a little bit of corrosion and there'll be no contact. You reflow it and it'll be fine.
I found another one I just fixed, and this was on a little radio. It's just the simplest, and it kills me. It's just like the simplest radios. Well, it's probably the ones that give you the most trouble because of the way that they're built. They're built cheap or whatever. It was an RCA, and it was a little AC All-American 5. But what they did, it had ground points coming off had miniature tubes, so it had ground points. You know how they have the ground points in the center of the tube sockets right there?
Mm-hmm.
What they did was they took a flow of solder, just like on a circuit board, only it was on a tube socket. You know where they ran it to? They ran it over to the rivet.
Oh, really?
On the tube socket, and that was to ground it to the chassis. And then, of course, your rivet loosens up over time, and it's on a phenolic, and then the ground was really poor.
Yeah.
I was getting like 8, up to 10 ohms. So on that, and so then I found that, and it was pretty simple. What I did was I just built a solder place on the chassis, and I just ran wires over to those to make up for that, to give both of them good grounds. But grounds can be a real troublemaker, on all kinds of things, and whether it's radios, cars, lamps, whatever the heck it is, poor grounds can just cause you a big headaches.
And here's an exact example of that. Great lead into this. As you can see, it says common here. Here's your common ground load. And if you look at this, someone did the solder, but it actually didn't flow into the copper. It's just sitting right on top, just like Mike's rivet was. And so this was not making contact here. And over time, when it was first built, this is the way it came from the factory. And when it was first built, there was enough contact that it worked great. But over time, you start getting some oxidation, things like that under it. And then pretty soon that contact isn't making contact anymore. And again, this is one where I just reflowed it and then it started working. So, that's just some examples of just visual troubleshooting. It doesn't take much if you go look in the spots where I knew where there was going to be power. I knew where it was going to be a high current area, and immediately I started finding the problems. If you feel switches and they feel mushy, they may not actually be making good contact. I've found batteries not installed in the right direction. There might be a reset switch hidden somewhere in the electronics. Anytime you see burned or discolored connectors, good place to look. There's quite often, especially like the Molex connectors, the white ones. If they start getting brown, it usually means that inside the connectors themselves have corroded, and they're making a bad connection, because that bad connection creates heat and then it'll discolor the connector. So if you see anything like that, don't gloss over it and think, oh, I'll have to get back to that. That could easily be an indication of what your problems are. Any solder joints, on printed circuit boards or point to points, if they don't look shiny or they don't look like they're connected well, double check them. I was watching a YouTube video on a guy working on a All-American 5, and he got looking and he noticed that there was 2 wires on the lug that actually never even got soldered. They were wrapped, but they never soldered. So all of those kind of things you want to kind of look at. You can always wiggle wires, see if it changes something. Looking for dirty contacts. Dirty contacts, especially like in variable resistors or rheostats, things like that. If that wiper gets really dirty to where it's not making contact, it can actually just make everything not look like it's working. I've seen quite a few rheostats to where it burns on one end or the other, and where it doesn't make a connection anymore. So, a lot of times ohming those out will tell you what's going on. On mechanical things, I always look for wear, misalignments. If I see things that are sloppy, if I see any rub marks, or I always look for little black deposits or gray deposits to where something is rubbing and falling in the case. Those kind of things are great indicators that there's something going on. And a lot of things, it doesn't take too much wear before all of a sudden, it'll start creating more catastrophic failures. And then the last thing is, when you're, if you're really struggling with stuff, think outside the box. Step back and go, how could I do this a little bit different? And actually, if you don't mind, I'm going to share something else here. I'm going to go to Christian sent me his schematic we were talking about earlier. And I'm going to share that. And then maybe we can discuss about, some other troubleshooting techniques on how to do this. So this is the schematic that Christian had. I hope you don't mind me doing this, Christian. But, it's a relatively simple circuit. It should be relatively easy to fix. And my experience is a lot of times the simplest things are sometimes the hardest things to fix. The real complicated things, you can usually fix those pretty easy. The simple things, those are the ones that will drive you crazy. The approach that I would take, and I'd love to hear from everyone else, but the approach that I would take here is I would probably either disconnect here or here, and then I would look to see if I'm getting, this is acting as an amplifier here. I'd look to see if I'm getting some kind of amplification at this point. Then I would make a disconnection here, and I would check to see if this node was amplifying, and then, look on out later. But that's the kind of thing I would take a look at. I would, if I couldn't obviously see the problem, I might try breaking it apart and looking at it individually, if that's easy enough to do. And this is where a signal tracer or even like an audio amplifier, you could, if you put an input signal in here and you had something as simple as like this little Radio Shack audio amplifier, you could take something like this and then just feed that into the input here. I might add a capacitor in series with it to block the DC, but I would just touch it here and see if I could get any kind of amplification of the signal through. That'll quickly tell me this part is okay or it's not. Then I would disconnect this one and then I would try at this point here. And then if that doesn't work, then I would, I could figure out if I break this and I'm getting no amplification at this point, that kind of tells me there's something wrong here. Maybe this capacitor is open, something like that.
Yeah, I replaced that capacitor.
So just looking at this, my first idea is that, Q1 must be clipping the hell out of the signal
Yes.
because there's no bias on the transistor, right? So it's only going to take the half, the half the waveform, whichever polarity, right?
Well, there's
Because you're going to get
bias.
AC on the
That's
right hand side of that capacitor, but the transistor, emitter is connected to ground, so it's only going to
The
conduct
emitter
half the wave.
The emitter on Q2 is on ground too.
Yeah. So these are
Yeah,
PNPs,
similarly, yeah.
right? These are PNPs.
Yeah.
Keep that in mind.
Well,
yeah,
regardless, you're only going to get half the waveform.
Exactly. And that's why I had asked Christian if he had a oscilloscope because it would help. But you could use something like a signal tracer, and that's where all you need to do is, if you fed a signal in here, I might disconnect this just to make it a little bit easier. But I would look at this collector and see because what's happening is as this base moves, I should see big movements here, and it's going to go. When this shorts out, it's going to be at ground level, or it's going to be up to the 9-volt level or darn close to it. And so I would look to see that. And you should be able to, put a simple little amplifier on here if you don't have an oscilloscope and check that out.
But the fact that these are germanium is going to make a whole lot of difference in the way it clips. And what's that collector thing in Q3? Is that 8KZ or 8?
That's an 8K too.
I just don't know what this.
That's a resistor 8K too. That's for
I don't know what the 2 means.
I don't either.
I'm just saying.
8.2K.
Oh,
I see. Okay.
Oh, yeah.
You guys don't write your resistors out that way?
No, I write
I've seen
8.2K.
I've seen that done. I've seen it
Yeah.
done that way, but normally I don't. But I've seen some designations that are like that.
The newer CAD tools like to see that kind of stuff for voltages. I haven't seen it for resistors so much, but yeah.
I have, but not too often.
Yeah, they do it on all of the surface mount, the SMD stuff. They're that way. I just hadn't seen anything old written that way before.
It's because their parsers are so primitive.
Yeah. But in thinking about how would you guys go about troubleshooting this, my thought would be to break it apart and just because it's so simple, just open this up, check here, open this up, check here. That's going to help identify it pretty quick.
That's basically what I do, I usually work on tube sets, but it's the same thing. You want to isolate what stage is giving you the problem. And what's basically what it comes right down to.
Well, at the problem that what I've done up so far, I initially built this with PNP silicon transistors. I've built this schematic before with the germanium PNPs. Anyway, when I'd try and push a signal through it, it really didn't want to come out. There was a hint. And so I was trying to maybe even think of because based on Mike's last talk of transistors, I was seeing that, switching this circuit and building it as silicon, that's where I had a problem with voltage or current. And so I started eliminating, at this point, I started eliminating the higher resistors and lowering their values, trying to see if I could get anything to kind of flow or work. And I was unable to do it. So then I took Q1 and replaced it with the PNP germanium. And I thought I heard something out of the output, not much. And then after I replaced then Q2, I wasn't getting any sound. So I just went ahead and replaced Q3. And on Q3, on the collector, as soon as I touch it to the 8K2 resistor, it'd go down from approximately 9 volts down to 1 volt.
Yeah, and that's happening probably because you've got the reason this, if you're looking at this collector here, right?
Yes.
And it drops down to 1 volt or something like that. That's because this thing is turned on. So it's on, think of it as a switch. And between the collector and the emitter, that's just a dead short. And what you've got coming down here is this must be set up to where, let's see, 8K to 1K. Yeah, that would be right. You would have, it's going to be your voltage divider. You've got 9K here total, right? With a 9 volt battery. And so if this is a dead short, you're going to have 1 volt at that point. So
Mike, can you tell me how the plus side of the battery gets to ground? Where's the path to ground from the plus side of the battery?
right here, I think it's this right here.
Does it short out when you push a plug into it or something?
Yeah, I
Yeah.
think, yeah,
Yep.
this is the on-off switch.
It's a stereo.
When you put the plug in, this connects to the shield. This touches the shield. This touches the pinpoint of it.
Oh, that makes sense.
And so they're using this like a switch, right? Because when the plug's not there, then the 9 volt battery is open.
Right.
That would be my guess.
Yeah, it's a stereo jack.
Yeah, so this is working because you would expect 1 volt here, right? Because if you pretend that this is a dead short, and you've got a 9 volt battery going from here to ground, well, you're going to actually have a little bit of voltage drop here too. But you're going to have roughly 8 volts dropped there and 1 volt dropped across this. So,
And now on my other circuits, I've got 6.5 volts there.
well, so what that means is this transistor is turned on. That's what that means. Would everyone agree with me? Or anyone agree with me? Linda, please.
Oh, yes.
Yeah, so with this turned on, now your question is, why is that transistor turned on? Now, maybe the transistor is bad and it's shorted. That's one possibility. Or it could be that this one is turned off, because if this one's turned off, now you've got that voltage going between the base to emitter through this 100K resistor here. And so if this one's turned off, this one's turned on. When this one turns on, think of it again as a switch between the collector and the emitter. When this turns on, this goes to ground, right? When that goes to ground, this transistor turns off. And you could actually, if you wanted to put your voltmeter on the collector here, and you should be getting your -9 volts, right? Or -8 volt or 1 volt or whatever it is. If you
On my other circuit that works, and they all work, the adjustment for that bias or the voltage on that collector, the 8K2 is affected if you were to raise or lower that, and that would affect the voltage on that transistor.
Right, but what I'm saying, what you can do is you could take a jumper wire and go between this base and ground. That's acting like the, that's pretending that you turn this transistor on, right? You can just go ahead and short this, the base on Q3 to ground. That should turn this transistor off and you should see this jump up to 9 volts. If you're not,
I thought you shorted the base to the emitter to turn it off.
between,
Well,
Well,
it's gonna go to,
I
It
was
will
just,
go to the-
acting as though, I was making this switch for him just by, and to start with, if you just shorted those two, that would be like that transistor's turned on, right?
Yes,
So I was just saying, if he could start here by saying, if you take this wire here on the base of Q3 and you just drive it to ground, you should see your 1 volt on the collector go up higher. That'll tell you that this transistor is working. Then you could do what Larry mentioned, is go up here and then try injecting a voltage on your base here. And by turning this all the way down to ground, you should be able to see it. Let's see, if you turn this one to ground, this would turn off. And so that means this turns on, and that's your 1 volt, which is, I'm guessing, what's actually going on right now. Your problem could be actually up in here. It could be that this transistor is never going. Let's see, this needs to go higher. And so this has to
There-
go
I
low.
think there's about 2 volts or so on the collector of 2.
2
So
volts.
right there would be about 2 volts.
That's not right.
And on the other circuit, it's, I mean, I'm only looking at, or going by some memory, it's either 0.3 volts or 3 volts. It might be 0.3 volts
See,
on the one that works.
a lot of this is going to depend on what your input is, right? And the thing is, keep in mind, the way this thing is working is you're passing in an alternating signal.
I'm not putting a signal on it. I just put a grounded input plug on it to check it, to turn it on.
So this is ground here.
Yeah, but that
No,
Q3
that's the
thing,
input. I stick a grounded input plug in there to turn the battery on.
yes.
that
check this.
Q2, Q3 thing is an oscillator. Because see,
But anyway,
Q2 is biased at 100K on both the base
Yeah,
and
so
the collector.
this is a feedback here.
Yeah, and so what you're hitting it with is some AC thing, and then it rings for a while.
And that probably gives a distortion or something.
Yeah, exactly.
But what I was proposing was more of like a DC test, right? Just to see if these parts of the circuit are working.
Yeah, but the DC basically would be such that it's stable until it gets hit with an AC.
Oh, I agree. I mean, it may be that this isn't oscillating. I definitely agree with that. But I was just referring to the fact you could do a DC troubleshooting just to make sure that you can actually toggle these things, or that, maybe he's got a broken wire up in here or something like
Yeah,
that.
it should be sitting to the point of where it's ready to oscillate. I mean, basically, right on the edge.
Yep.
Yeah, I'm just comparing another working circuit and testing it at points.
Yeah, the problem is you're using like an AC meter, which is going to give you RMS, and so you're really not seeing the true signal, what's going on.
So my multimeter is set to DC, and I don't have a signal coming through. I'm just checking voltages or continuity. But I don't have a signal coming into the circuit when I'm testing it. I'm just putting in a input jack
Yes.
male, and it's grounded, so it turns the battery on.
Right,
at the input, and then I check the voltages based on the other working circuit that I have built already.
which is a great thing to do.
So I'm just troubleshooting and looking at what I do or don't have and why
Right,
it is or is different. And like I said, I've built these before. I didn't have any. This is the one that is causing a problem without me. I guess you'd say, like I told you, I built another pedal and I was 24 or 5 hours on it, replacing every single component, jacks, potentiometers, and of course, checking or testing the components, with meters before I put them in, and it never worked.
well,
There's
to the
nothing
point-
there. There's nothing there to go bad.
well, the one thing that is tricky is probably this oscillator here. And then you guys can help me here, but this is, I believe, feedback, right? Coming back in. And so it's
Yeah.
gonna create it to ring or oscillate. The thing is, if these things aren't matched well, it's possible that it may not ring and it may just lock up.
Well, they are matched as far as testing. I built them before. And so I checked the transistors on a peak meter and I adjust it for 9 volts as far as the calculation. I've built them before.
No.
And so it's not-
What I'm saying is the physical transistors that you have,
Uh-huh.
maybe if you've got one that's not coming on the same as the other one, and the oscillator circuits are really tricky. And well, I guess it's kind of like the amplifier tubes, right? If you've got a push pull or something like that, and they're not balanced exactly, you can get some problems. It's kind of like that. Even though these might be the exact same transistor, if one of them is a little bit out of spec, it could maybe affect the oscillator.
He's talking
Yeah,
about the one.
I've tried on other circuits, as far as, I don't know, say the Hefe on Q1 is 60, Hefe on Q2 is 70, and the Hefe on Q3 is 90. That circuit generally and will always work. If I've got them all at 50 and 60 and even 40, the unit or the schematic circuit always works. And so I have a problem somewhere.
Take them out and put them in the one that works. See if they work in the one that works.
Yeah, I mean, like I said, I meter all these transistors before I use them. So
Larry is suggesting taking one of the transistors out of the one that's not working and putting it into the one that does work. And then see
Yeah,
if the one that does work still works.
A meter's not good enough, Kristen.
I spent $80 on the transistor meter and it has never failed me yet. If it's bad, it shows it's bad.
Yeah, but it doesn't tell you how matched they are.
You spend
Yes, it does.
You can spend $30,000 on a car and you'll still have a bad water pump.
I know, but anyway, the meter I bought and I've used it for years, it works. And then I already built a simple meter and this meter runs on 12 volts. So when I adjust it from 12 volts down to 9 volts in the calculation, it still comes up, does what I need to as far as finding out the gain and or the forward current, that it tells me if it's a germanium or it's a silicon. It's not a multimeter. It's built specifically for checking transistors.
Okay, the only choice you got left is take them out one by one and try them in the other one that does work. Let's see if it'll perform in the other one.
Well, the problem with this circuit in the first place, it never really worked properly because I built this circuit with silicon transistors, PNP, and it never worked because it's still, I don't understand, I'm not the designer. And so I replaced them back all the way through with the germanium transistors and I'm still not getting it to work. And I have a definite problem checking the collector on Q3 to show me when I connect the connector to the 8.2 resistor, it takes it down from almost, or whatever, under 9, a little under 9 volts. It'll take it down to 1 volt.
And again,
that
that's
cord.
because that transistor is on hard.
Yeah, okay.
Yeah, it's
Hey,
pulling
hey,
it
you
down.
guys. Hey, I'm dying on the vine here. I've had a long day, so I'm gonna let you go. You guys take care and have fun with this. We'll see you next week.
All right, well, thank you.
You
Thanks
bet.
for all your help, Mike. I always
You
appreciate
bet.
it.
Yeah, you too, Mike. Thanks a lot for everything and all your help on all those problems. So you guys
Okay.
all have a good evening. I'll see you next week.
All right.
Good night, Mike.
And all I can tell you is I've built this exact same circuit many times. And it's always worked. Or if it hasn't, I've found the problem simply or fairly quickly.
Sorry, don't know what to tell you then.
Yep.
I know that's where I just could usually come to a point, just like I did with another, when I came to the wall with another one. I just built another one that works just fine.
Yep.
And I went through, I replaced all the parts. I spent 25 extra hours on that one trying to figure out what in the world. So I would know what in the world is wrong with this, why it won't work. And I never found that. And this is only the second time this has happened. That I have not figured out why something doesn't work.
It's always a struggle.
Well, I just go so far until like the last one. I haven't had a problem since that last one that I was going to find out what was wrong with it and what specific point and component, and it replaced every one of them, and it still didn't work.
Well, I don't have anything else. So thanks, everyone.
All right,
Yeah,
thank you.
I gotta go to bed too. Had a rough day. Let us know, Christian, if you find what's wrong with it.
Yeah, that's the whole the mystery of whatever you're working on. Are you gonna, or I'll just build another one and say, I don't have 8 more hours to spend on this one.
Yeah, just use it for parts.
Yeah, just put it on something else and just figure I don't know what happened. Mystery.
Yeah, I'm
Okay,
gonna head out. I'm gonna head out myself. Have a nice evening, guys. See you next week.
All right.
Yep.
See ya.
Howdy. There, Franklin. Good night, all.
Good night,
Hey,
Mark.
Yeah.
I just save bandwidth by leaving my video off.
I was in and out of the room there, but
Well, my wife's streaming in the other room, so I'm pretty far from the router.
so what's it doing over there?
Oh, not much. Helicopters lately.
Helicopters lately?
Lately, I'm working on an SX-17
Oh,
for
okay.
someone. It just needs, I'm just doing power supply and basic stuff, wax caps and things, making it safe. And then I have a SX-28 under the table that I'm going to start working on here pretty soon.
Yeah.
That'll be a long-term project, I think.
Yeah. Well, my Sky Buddy's been a long-term project because I basically haven't got back to it.
I know I've been carrying my friend's SX-17 around for like 3 years, back and forth to Idaho and everything.
Yeah. You get all settled in now, back to Portland?
Yeah. Except I don't have an antenna up yet. Haven't
Oh,
figured out what I'm going to do about that. Throw some wire in the neighbor's tree or something.
oh, okay. Yeah, I got a good neighbor. Lets me anchor a wire off in their palm tree, so.
Yeah, she's got a cedar tree that's probably, I don't know, I'd guess 70, 80 feet. So I could probably just run a vertical wire up it and some ground wire out in the grass and
Yeah,
have a good vertical. I don't know.
so you don't have any trees in your property, huh?
Just a couple of small apple trees.
Oh. Can you put a tower up?
You know, I'm unincorporated Washington County, so I probably could.
Oh, okay, so you don't have CCNRs hanging over your head.
Nope, not at all.
Okay, that's good, so,
Our neighborhood's about 30 years old. I think there originally were, but they expired when the last lot was built out.
really? Oh, that's a nice one.
Well,
Ours
that's
is
kind of,
specifically written that it keeps going forever.
yeah, I think that I've seen that before where, in fact, my other one, the other lot we lived on up in Beaverton, actually, it was unincorporated law as well. And that neighborhood also just had the HOA just died after, I don't know,
Yeah.
25 years or something. Obviously, nobody paid attention to it.
Uh, Yeah, see, now see, we don't have any active HOA. It's just the legal paperwork that says thou shall not do this and that. So if you get somebody mad and they want to sue you, then, they'd have that hanging over your head.
Yeah.
Yeah.
Well, I
I
think
just-
I haven't checked with Washington County to be sure. But I don't think I have to get a permit unless my antenna could fall on a neighbor's yard or something.
Yeah,
And then I would have to do a permit with a wet stamp for the antenna design. So I probably could do a tower. I might have to go through some steps,
yeah.
but at this point, I probably won't do a tower. We'll see.
Yeah. Well, I put in, I mean, on my, down south where I have a cabin, there's no CC, there's no nothing down there. So you could pretty much, it's the Wild West. And, I bought a used 30-foot tower and the guy had a hand crank to lay it over. So I set it up that way. So,
Yeah.
thinking in the future that, other than the fact that as long as I'm strong enough to run the hand crank,
Yeah.
that I can lay it over on the ground and work on it. So that's what I was thinking of, because someday I won't want to be trying to climb it or anything anymore. It's no big deal, especially if just 30 feet's not. I was used to doing that stuff all the time. So
Yeah. Yeah, I didn't have any issue. I could have done anything I wanted in Idaho, probably up to 300 feet, but
wow, yeah,
that was the Wild West out there.
yeah. That's kind of, well, yeah, I suppose so. Well, actually, and I mean, if I'm in the county in Hawaii County, you have to get a permit of some sort, but it's complaint driven. So if nobody complains, and out there it's not likely anybody complain, then they don't really they don't go looking for trouble. I have a neighbor that's an actual building inspector, so. And I asked him about those different things. He says it's all complaint driven. So somebody complains, then they have to go look, and look for violations and what have you. But if you don't get in a pissing match with your neighbors and stuff, and they don't complain, then
Right.
then it's so that's kind of the way it is. So that's kind of good actually. They have too much work to do.
Yeah,
To go look for
everybody out in that country that I ran into is so busy
Yeah.
just with daily life, whether it's firewood in the summertime to keep warm in the winter, or building a new building, or taking care of livestock or agriculture. Everybody is so busy that they don't have time to rag on their neighbors about stuff. And people are, very, very down to earth and practical. And and in some ways, the people around me, my neighbors, were pretty excited to have someone with an amateur radio
Oh,
nearby.
really?
Because I could talk to the repeaters up on above Boise, and
Oh, you're talking about up there in Idaho. Okay, yes.
yeah, and so I just didn't have any trouble with the neighbors. Here, who knows? This neighborhood is houses are about 30 to 40 years old. It's probably an initial Intel neighborhood for the Intel plant on Canyon and 198th.
Mm-hmm.
So this neighborhood was probably built for original Intel employees, I suppose. Many of whom are still here in the neighborhood 30 years or 40 years later. So I don't know. It's a nice little neighborhood for now.
That's good.
We'll
And-
see. We'll see what happens.
Yeah, and hopefully there's nothing deteriorating nearby, like some of the place. God, I can't believe how bad it is in some places in Portland. It's just crazy.
Well, there is a thing going on. Yeah, Portland is bad.
It's insane.
There is a houseless persons, homeless for shorthand, pod thing supposedly planned for down the street, a VLO Methodist church. They're talking about putting 30 pods on their parking lot temporarily for homeless people.
Mm-hmm.
But they had it, so the way Washington County is doing it, they actually started talking about it in 2021 and worked on all the details until the timeline, the main point in the timeline of informing the community. Now that all the contracts are let, the ground is surveyed, and they're ready to go forward, now they involve the community and the public. So it's very backwards. And the neighborhood behind me, which does have an HOA, Shadowwood, they've actually hired an attorney, and I think they're going to go hard after the county about it, because there was no public
Yeah,
input prior to letting the contracts, which is pretty crazy.
no, you said there's no. Oh, you mean contracts as for, or you mean contact or contracts? I missed that.
Contracts. So the county let the contracts for the community services
Yep.
LLC that's going to provide the support, and they must have some kind of contract with the Methodist Church, who somehow will be remunerated for letting the county use their parking lot. We don't know any of that, right? Nobody
Yeah.
was informed, and we weren't informed that that was a project in the neighborhood and the property disclosures when we bought this house. So we don't know what's going on yet, but we'll figure it out.
Wow. Yeah, it sounds like they're just kind of trying to. Somebody finally realized they got to cover their tail.
Right.
Oh, geez.
Right. Well, I mean, Oregon kind of has been that way for a while. Let's do it, and then we'll worry about the people later. So, they're talking about tolling I-5 and 405 from the bridge in Wilsonville across, I forget what you call it, the main bridge on I-5 to
Yeah,
Vancouver.
they're talking about the interstate bridge and the I-205. Yeah.
Yeah,
Glen Jackson.
and 405. And
405. Okay. Oh, I mean the Fremont?
yeah,
What, really?
well, the one that's over by Gresham, right? That goes to Vancouver.
That's the Glen Jackson. That's the 205 bridge.
So 405, I don't know, I don't go
No,
down.
that's 205. That's I-205.
Yeah, I
405
never,
is, the 405
Right.
is the one that goes from I-5 across the Willamette and feeds at 26 and stuff.
oh, yeah.
I think I said that right.
Yeah, I get,
Yep.
I understand. I don't go down there at all. I haven't gone down to downtown Portland for years.
So,
We live
okay.
out here on the west side, you know?
And you're staying out there. Okay.
We stay out here.
Yeah.
But that's what ODOT did. ODOT did all the preparatory stuff, came out, made the rules, made the plans, and said, we're gonna start tolling. And enough people from Clackamas have made a ruckus about it that Governor Kotek just postponed the whole deal till 2026 now.
Hmm.
Because enough people are saying ODOT didn't include the community in their planning,
Wow.
which is a tip. I mean, I know how that works. I was at
Yeah,
the-
I guess so. I mean, I don't, I mean, because see, I was over Washington and I worked for WASDOT and I was a radio tech, but still, you know, I'd see things going on. And I don't think that they get away with things like that. But there are things I know that it, like with the interstate, you know, the interstate crossing, interstate bridge replacement, some of the work they were doing for years, figuring out costs and stuff, but they have to do that to bring out a proposal saying, okay, they got to do that preliminary work, figure out what's all this stuff's going to cost, so they can say, we think it's going to cost this much, and to do this, and now what do you think? So there's some things that they do ahead of time, but as far as like making a policy like you're talking about, that's like, I don't think that would fly. I don't believe, but of course I've been away from that since 2015, but
Yeah, well, in the state with one party, they
yeah.
make their own rules.
Well, that's
And I think
the
they,
same way. Yeah, the state with one party is up here to Washington too,
yeah,
and Hawaii.
and it's interesting because this whole recent health emergency brought something to politics that really hasn't existed before, and that is rule or governance by emergency declaration. And so if you can claim a transportation emergency, then ODOT says there's a transportation emergency in Oregon, then that kicks off a set of rules that they can follow that lets them bypass a lot of community input, a lot of those kind of things. And, basically the governance in almost all states during the pandemic did the same thing.
Mhm.
We have a health emergency, the governor takes control, emergency control, the legislature gets put on the back.
Yeah. The King Inslee did that stuff. I know. So
Yeah. Well, so did America. So did our states.
yeah.
Hawaii too, I mean.
Yeah, and Hawaii did that to some extent like that too. But yeah.
So it's kind of interesting, I mean, that, and now, I mean, the governor's health emergency thing in Oregon was actually predicated on I think it was 2012, voter referendum that basically was implemented with the thought of tsunami emergency in Oregon, tsunami disaster. But included in that disaster emergency declaration legislation was also conflagration, like forest fire, So the governor can declare emergency without legislative input, just kind of like the War Powers Act, you know?
Yeah. Huh.
And so the governor can declare an emergency. She declares an emergency, starts closing things, starts, saying small businesses have to do this and that. And, it made a big mess here because Governor Kate Brown, of course, took advantage of that to achieve some of the outcomes that she wanted to achieve and could achieve by emergency declaration that she couldn't achieve through legislative action, even with the legislature being single party legislature. They wouldn't go along with it. So
Fun
and
stuff.
that's one of the reasons we went to Idaho.
Yeah. Yeah.
And if this place turns crazy, we'll go back
Yeah.
or somewhere else. I don't know, somewhere warmer without so
Yeah.
much dust.
Yeah. Well, it's all pretty much one party over here. So I just look at the mess and just go like, well, geez, what do you expect?
Yeah.
But
Well, the question is, will people come to their senses and realizing that their choices are costing them something that's pretty dear, and that's
Yeah.
their freedoms,
yeah, I don't know.
I don't know if they will or not.
Hey, Mr. Franklin, are you on board?
What's that?
I just wonder if Franklin was on board there.
I haven't heard him for some time.
Yeah, maybe he must have walked away there. No. Yeah.
I'm getting a bunch of texts. I need to sign off here.
Yeah. All right. I need to get going there too, do some things. So it's good
All
to
right,
see you
we'll-
guys are alive and kicking over there.
Yeah, we'll leave the room to Franklin.
All right. We'll see you later, Mark. Take care.
Okay, have a good evening.
Yeah.
or
Yes. Good
afternoon.
evening. You too.
Okay, bye for now.